So we just have a little loop set up so you can see a little bit of autonomous driving here at the airport. So right now the car's in manual mode. It operates like any other car. How this car is different is I can flip this switch in the center console here. I've put the car into autonomous mode. So
sorry, say that again.
When I flip this switch, it puts the car into autonomous mode. So now the car's driving itself. Everything is computer controlled. You can see the steering wheel moving. You can feel the speed changing. But I'm not touching the pedals or the steering wheel.
And the sensors are sensing various things in the environment that show up as different colors, Jersey barriers, signs, poles.
How does it know what the speed limit is?
The speed limit is something that we put in a file that it reads. So the computer has that as something that's available to it.
So it's like a navigation system that you have in your car. It has a map of all the roads, how the roads are connected, and also what the maximum speed is on that road. However, we don't program the speed of the car. So right now it decides how fast to drive based on the road geometry, based on the other cars around it. It just knows what the maximum speed that it's allowed to drive is.
If you look at the screen, it's planning a route in front of it that the preferred route down the center line is red, and then it's got some white choices around it, and those would be taken if there were an obstacle that we had to avoid.
You can see it just gave a turn signal. It's taking this ramp to get onto 376.
Now, what would happen if a deer would, say, run out in front of us?
It would stop. Stop and maybe try to avoid it. Depending on what the options were. If there's Jersey barriers and things like that, it would try to stop. If there's room for it to safely maneuver around it, it would try to maneuver around it. So we have a special setup right now. Normally you just give it a destination. So this morning when we left from Cranberry, we just told it we want to go to the airport. It figured out the route, drove itself to the airport. Here, we basically told it to drive down here to this exit and then back to the airport. So this is just a loop that keeps us nearby so you can see some of the features.
Can you do it by voice command, or do you have to program it?
It's like a navigation system in your car, so you can put in the destination and then it will figure out the best way to get there. In cars that are available today, it then guides you as you drive. This car does the driving for you.
Yeah, we don't have the ability to command it by voice, but if we added that module to it, there's nothing that would fundamentally prevent us from doing that.
Unfortunately, there's not a lot of traffic right now to see interactions.
Yeah, the first time we had a couple of vehicles coming from the left that we waited for at that stop sign.
And so we talked about the fact that it has maps. You can see the blue lines here is a map of this ramp. But you can see these other lines that are being, see this one and this one that are being drawn. That's the car actually detecting where the real road is. So GPS has some error, maps have some error, so we need to be able to actually sense the road and to make sure that we're driving in the right place.
And to do that, it's using a camera to see the white lines just the way that we do.
Raj Kumar.
What?
I'm professor of electrical and computer engineering and robotics at Carnegie Mellon University.
In lay terms, what's up with this car? What's the significance here?
So this car has been ramped up with a bunch of sensors, lasers, radars, and cameras. So those sensors essentially sense what is happening around the vehicle right? Who's moving where? Is there a guardrail? Is there somebody moving out there? It gets all that information from the sensors, processes them using a bunch of computers, and decides what is where, and then decides to move forward. And it sends commands to the brakes, to the gas pedal, to the transmission shift, to the turn signals to move the vehicle forward at different speeds.
In this technology, is it a maybe or will it happen?
It will happen, and it's already beginning to happen. Some of these technologies are getting into modern cars. For example, there are cars on the market which can park themselves. There are vehicles that can actually do what is called adaptive cruise control. If there is a car in front of your car is using cruise control, but there's a car in your lane in front of you driving at a slower speed, with normal cruise control, you have to cancel cruise control before hitting the other car. With adaptive cruise control, it automatically senses the car in front of you, slows down automatically to the speed of that car. So it's adaptive. So this technology is already beginning to get into today's cars, and they will get smarter and smarter, safer and safer, and the humans will be doing less and less work. At some point in time, somewhere in the 2020s, you would not have to do any work. The vehicle will drive itself.
And you're talking 2020?
2020, the technology will be there. 2020s, that decade, we'll basically see this technology being spread in practice.
And the key is to get it down to it's affordable, correct?
That, and getting the technology to work in all day-to-day conditions, and then getting the costs under control and making sure that the legal structure is in place, the insurance infrastructure is in place, and society at large understands and appreciates the convenience that this technology brings to the table.
And with, you were saying, with more cars, the higher number, the price will come down, and your goal is around, you're saying hopefully around $7,000?
$5,000 to $7,000 is the target price point for this capability of the vehicle being driving itself. Right? You still have to buy the car. You would think of this as an option that you buy. It'll cost $5,000 to $7,000, and that's the long-term objective.
All right. And how long has this technology been developed?
We have been working on this technology since 2006. These project members, this vehicle that you see today, we bought it off the dealer's lot in 2011, and we basically equipped it with this technology.
What happens if this car has an accident?
Well, that's what remains to be seen. Is these cars will have accidents. I mean, you're not going to go down to zero, but we can significantly reduce the accidents. Over 32,000 deaths on the highways in America every year. That will be drastically reduced because these cars, smart cars, they're gonna sense things that humans don't do today. So it'll be much safer out there on the road. So I think that's something we have to look at. But I really think that this technology is something that we have to embrace. We got to figure out how it moves forward and how we get it out there and how we build our roads of the future to incorporate this technology.
So who's to blame if there is an accident?
Well, I have no idea. I mean, again, that's something that remains to be seen. But again, we're going to see significant reductions in fatalities, 32,000 a year, significant reductions in millions of accidents every year where people are injured. That's going to go down drastically. So this is something that's going to be very, very positive for safety and efficiency.
Does funding for this kind of technology become more viable because it does have a military component? And in fact, it could be used on the battlefield or in some military sense.
That's part of the initial phases of this was DARPA, the advanced research that the Defense Department does. That's what they won their competition in 2007. We saw UAVs were developed for the Defense Department, and now today UAVs are being used commercially for various things. So I think that the viability is there. It's going to be extremely important to be able to take our men and women out of harm's way on the battlefield and send these vehicles in to do the stuff that needs to be done. So again, that has a component to it, but I think by and large, the biggest component is going to be commercialization of this. Roadways are going to be safer, they're going to be more efficient, not only for the traveling public, but also for our commercial fleets, our trucking fleets that are out there on the highways.
Are there any major concerns, though? I mean, a driverless car?
Well, as an individual, when I got in the car, as I said there, I was, I had a little concern. I was getting in a car that somebody wasn't going to be on the gas and the brake and the steering wheel, but it became very apparent to me very quickly that this car the technology's there, that it can do what they've designed it to do, and so I believe I'm speaking for the secretary, but we both felt very comfortable in the car carrying on a conversation, and again, I really had no nerves out there after it got started.
And this isn't a might happen, this will happen.
Well, it's happening today. As the Secretary mentioned, as I mentioned, elements of this technology are already into automobiles today. They're already into our big commercial truck fleets today. It's just a matter of this, we're rolling it out, so we'll have more and more of this technology until you will have a car like this that's affordable, that the average American will buy, and the technology will make his drive safer and more efficient.
Phil, I wonder while you're here if I could ask you just a second about what's going on in Syria
Sure,
and
sure.
where you're, obviously the next couple of weeks are going to be very important. What's your feeling? Have you made up your mind, and what's going to be happening in D.C.?
Well, I've got to tell you, I'm very skeptical about what the president has proposed. I'm going to go to Washington next week and listen to the president. I think he's commander in chief. You owe that to him to listen. But I'm on the Armed Services Committee. I've been in touch with folks on the Intelligence Committee. We've talked through a number of these issues. I have great concerns about weakening the leadership in Syria that would allow Al-Qaeda to be able to get WMD, and that's something we definitely don't want. This guy's terrible. Mm-hmm. He's despicable. He needs to go. But again, weakening him, does that make the worse actor be able to have the control of the WMD? And that's a great concern of mine today. So that's something they've got to answer those questions for me before I'm ready to make a decision.
At what point is it? You asked me when I thought it might happen. So if 30% of the fleet has it in the early 2020s, should we start designing things differently? When should we start? Somebody asked the question today, when should we start building things into the infrastructure that are communicating back, that have special communications equipment and capability that can communicate with the fleet? At what point should we start doing that based on when we think the fleet might turn over? And then at what point, if a high percentage of the fleet is autonomous, do we make different decisions about how much capacity a lane can take? If the vehicles are self-platooning, like going through the tunnels, you get more capacity out of a lane. So maybe if we're looking at a project that's a brand new project that we're considering how many lanes to build, this technology might affect how many lanes we build.
So do you have answers for any of these things, or is the study
No,
still
it just started.
I mean,
It's just starting. We just kicked it off. We have a big kickoff conference in October to discuss the parameters of the study. But the big thing we're looking for is, we're going to leap to the assumption that the technology is in the fleet. So the real questions are, what does that change for us in investment strategies? When does it change it? And what has to be on our radar screen so that as we are looking at these investments, which, when we build a new highway, we want it to last 70, 80 years, well, forever in some cases with restoration and rehabilitation. But, we want to make sure we're building things into the system now so that we're not going back in a more expensive retrofit at a later time.
And you had mentioned things like just throwing things out there, but like paint, with technology.
Pavement marking, signing, the whole. I was talking to our driver on the way out here. It's amazing what a casual conversation we're having with him about this when he's not really driving the vehicle, and you kind of forget because the vehicle's handling it so well. But I said, how can we help by providing traffic control information around work zones? Should we provide that information electronically through our 511 system so that the fleet would have access to changing travel conditions beyond what the design standards might be? So temporary restrictions because of traffic control.
Because of construction.
Right, construction, lane restrictions, speed restrictions. What can we do with our design projects? Should we be providing those to, whether it's Google Earth or one of these platforms where theoretically the future fleet will be referencing? If we provide and upload our design information and specifications about the lane widths, the geometry, then they can import it directly into the system. So, those are some of the questions also about just on the technology side, how do we get good information to the users?
And you were mentioning, I'm sorry.
Do you see major overhaul in the system itself? I mean,
No.
Pennsylvania is always being criticized for construction, but
Right. No, I don't think a major overhaul. I think what you're looking at though is that, for example, if the entire fleet's autonomous at some point, we spend a lot of money on run off the road type things, clear zones and guide rail and things that basically protect people from running off the road. If the vehicles themselves aren't going to be running off the road, that changes that investment need. So I don't think it's a change of the roadway features, the number of lanes, the locations of the roads, but I think you're going to see a change in what we have to do for roadside protection, and maybe less. Even traffic control, stop signs, four-way stops. The demos we're seeing on this now is that the vehicles themselves will go through those and not need to stop. They'll slow and process the vehicles without the actual stop signs. So traffic control devices will change. Maybe the edge lanes and the information we provide and how it communicates back to vehicles might change. The physical location of the roads, no, that's not going to change.